Hello everyone. In this video, we will be discussing about what are the questions that are needed to be challenged in Polytechnic lecturers mechanical engineering examination. There are a total of 5 questions in which you can go for objection raising. Here, the first question is from the thermal engineering part. You can observe the question number is 74 here, and the question is given like this: a Rankine cycle is shown in the figure. Arrange the following process starting from process 1 to 2, process 2 to 3, process 3 to 4 and process 4 to 1. See, and the diagram that is given here is not related to Rankine cycle. In the question, this diagram is not related to Rankine cycle, and this one you all know, this is a diesel cycle diagram. Okay, so the correct diagram that he has to give for this particular question is either this PV diagram or TS diagram. He might take superheated condition or dry saturated condition or wet condition at the entry to the turbine. So if he might have given any of these two diagrams, then the question can be considered. Otherwise, this question might be deleted because the actual diagram is given as wrong. Okay, so this one question you can go for objection in thermal engineering subject. And for the reference, the page number 330 you can see in PK Nag textbook of Basic and Applied Thermodynamics 2nd edition. So this is the reference book which you can consider for raising the objection for this particular question. Now let us go for the next question. So the next question is from material science or metallurgy. See, which of the following materials has maximum ductility? The question number is 81 here, and he has given the answer as mild steel, but the actual answer is copper. Now the key is incorrect here, and I will show you the reference here. So this is the reference. You can see for copper it is 45, and for steel this ductility is 25. So copper should be the answer for this particular question, and the reference for this is Material Science and Engineering, an Introduction by William Callister. So this is a standard textbook you all know for Material Science and Engineering. So this textbook is considered as the reference, and the page number is 148. So 148 page, you can find that particular table, and this is the textbook reference. And you can see the 7th edition. Edition is 7th edition here. Okay, so this is the question from material science which you can raise for objection. Now let's go for the next question here. So the next question is from the strength of materials part. So stress strain diagram. So you can see in the stress strain diagram he has given DE zone here as ultimate limit in the question. So it is not ultimate limit. DE is strain hardening zone. DE is strain hardening zone here. So this is the explanation. If you want, you can take the screenshot of this one. So DE is strain hardening zone, and here the reference textbook that you can consider is Mechanics of Materials by Gere and Timoshenko. This is in 1.3 stress strain diagrams, page number 9 here. So this is the textbook which you can consider, and this is the actual diagram, and in the points it is mentioned. So you can see that point D, this is the ultimate stress point here. Okay, so try to use this as the reference in order to raise the objection for this particular question. Now coming to the next question. So this question is from Theory of Machines. The question number is 26 here. So this question, clearance. So actual clearance definition is something different, and here for clearance he said the radial distance from the top of the tooth to the bottom of the tooth. So this definition is actually for the total depth. So this is for the total depth. So this one you can raise as objection because the definition is incorrect. Now you can take the reference as Theory of Machines 3rd edition SS Ratan textbook, and the page number is 148. So in the page number 148 you have the clearance definition clearly. It is highlighted here, you can observe. Okay, and clearance is defined for mating gears only. Clearance is defined for mating gears only, that is mentioned here clearly. So you can see, and the page number that you can consider is 339 here. You can see here in gears 339 part is there. Okay. So clearance definition is highlighted here. This is the question that you can raise as objection in theory of machines topic. Now, one more question is there from industrial engineering. So let me show you that question also. Here, the question is like this. Here, the method when the job is to be released in the production process or into the production process is called. The question number is 129 here. See, the actual answer is dispatching. So dispatching is the answer, but he has given forward scheduling. So you can raise this question as objection, and I will show you the reference for you. So you can see this is the reference 7.18 dispatching. This is available in the textbook Industrial Engineering and Management by Dr. O.P. Khanna. So this is revised and enlarged edition, and it is from Dhanpat Rai Publications. So the page numbers that you can consider as reference here is 7.38, 7.39 of this particular book. Okay, and the definition goes like this. So dispatch function executes planning function. It is concerned with getting the work started. So dispatching ensures that the plans are properly implemented. It is the physical handing over of a manufacturing order to the operating facility, that is to a worker. So in the question also it is given in the same way, the method when the job is to be released into the production process. So the production process, it has to be released and it has to go to the worker, and as per the planning it should be produced and the plan should be executed. So dispatching will be the correct answer for this particular question. So you can raise objection. Once again I will show you the reference book here. So Industrial Engineering and Management by Dr. O.P. Khanna, revised and enlarged edition. So page number 738 and 739. Okay, so these are the questions that are to be raised for objections in the TSPSC board. Okay, thank you very much. All the best.